The study of climate science at Penn State is not exclusive to our department. It involves many facets of the Earth system, from oceans to ice sheets. And here in the College of Earth and Mineral Sciences, we are fortunate to have as a colleague renowned glaciologist, climate scientist, and science communicator, Dr. Richard Alley, who is Evan Pugh Professor in the Department of Geosciences. Thanks for joining us on Weather World, Richard.
Well, thank you, John. I'm a big fan.
Oh, you have spent a lot of time in really cold places, Antarctica, Greenland, drilling into the ice, bringing up ice cores. What can ice cores tell us, and how far back in time can they tell us?
Right, fantastic things, right? So 2 miles of ice, take a core, summer, winter, there's your age, you count down. How thick it is how much it snowed that year. In there, pollen, sea salt, dust from volcanoes, micrometeorites from space, lead from our mines. Anything that came through the air is in there, indications of temperature, and bubbles of old air. Oldest records, 800,000 years, and we're trying to push it farther.
So almost 1 million years of Earth history trapped in the ice.
Absolutely.
You mentioned the bubbles, which you can sample for ancient atmospheres. One of the gases that climate scientists are really interested in, carbon dioxide. One of your most interesting presentations, and I've seen a lot of them, talks about how carbon dioxide is a control knob on Earth's climate, the most important control knob. How do we know that?
Right, so 4 pieces. The first is physics. Physics that we knew in the 1800s, physics that was really worked out by the Air Force right after World War II, when they were worried about things like sensors on heat-seeking missiles and the CO2 interferes with the infrared radiation. The physics, we're raising CO2, it has a warming influence. Make physics useful, you put it in a model. And now the big groups are doing weather and climate with the same models. If you try to build an honest model that doesn't have warming from CO2, the Earth freezes over into a giant snowball. The models have been good. You and I share a couple of years. The models have been going long enough that we can test their predictions with the data. And the data are very clear. The warming, the pattern of warming, warming down here, cooling in the upper stratosphere, more warming in the Arctic winters, is what was predicted 30, 40 years ago. And then our histories. Climate has always changed, which proves that climate is changeable. Climate has always affected living things. That proves it's important. Climate has changed for a lot of reasons, but CO2 has been especially important. If we don't change our ways, we could cause as big a change as the biggest natural ones, and faster than almost anything in the history of Earth's climate by the time our students are old.
And along those lines, a few years ago, you hosted a PBS miniseries called Earth, the Operator's Manual, which to me kind of begs the question, what can we do to keep Earth operating at peak performance?
Yes, use our knowledge, right? So you know, right? 1900, a hurricane roared ashore in Galveston. 8,000 people died, right? Last year, a hurricane roared ashore. There were far more people in the firing line, and the death toll was about 100 times lower. Because we had built for it, we had fantastically better forecasts, and your colleagues had figured out how to make those forecasts useful. We used our knowledge. Most, not all, but most people listened. We have similar knowledge on a whole bunch of other things that matter to people. And if we use that knowledge, we actually end up with a bigger economy. We get more jobs. We get greater national security, improved health, and a cleaner environment, more consistent with the golden rule. I should never tell you what to do. Never. But I can tell you what we know, and a whole bunch of people can take that knowledge and figure out ways to make it useful.
Gotcha. You were actually a keynote speaker at the annual meeting of the American Meteorological Society, which I attend every year. You spoke about transforming communication in the environmental sciences. What was your main message to that group?
Yes, I think we have to do a better job of telling the full story and the good as well as the bad. You know as well as I do, we scientists want to make the forecast better. And we focus on what we don't know. And if you make a mistake, you're on there saying, oh, we goofed it last night, daggone it. But you almost never do. You get it right. And the weather forecasts are so important, not just the hurricane, but the tornadoes and droughts and floods and everything else, that the public, NOAA, National Weather Service, Penn State, you have made this freely available to everyone. But there's a whole industry of people who take this information and make it more useful for particular groups. And businesses with bottom lines spend real money because it's so valuable. The military has this long history of working with you here in meteorology at Penn State because bad forecasts lose battles and they endanger the nation. And I think we're really good as scientists at saying, well, we're not sure about this, we don't know that. But we're not as good at saying, but we do know so much, and it's so useful, and it's so valuable. And I think your community in particular needs to brag a little more.
Okay. We'll take that to heart. We just have a few seconds left. I want to give you a chance to plug a very popular online course that you teach called Geology of the National Parks. What's the secret sauce that makes that course a favorite?
Well, the parks are fantastic. We got a dozen advanced students. We took them to the bottom of the Grand Canyon. They filmed what they saw with WPSU, and they made this available to everyone. And students seeing the most beautiful things on Earth and making it available to everyone is just wonderful.
Geology of the National Parks, Dr. Richard Alley. Richard, thank you so much for stopping by on Weather World.
A real pleasure. Thank you, John.
And we will be back in a moment with a recap of the short-range forecast.